So Thomas Lee he explained how he did it, but it's not data provided by Airbnb. Is that he built a tool to get the prices from the internet, from the website, in an automatic fashion. And you have plenty of cities here. So I took Frankfurt because I thought it would be more interesting. At least we know the neighborhoods. And the data looks a bit like this. So you have a room ID, survey, host ID, which kind of room it is, country, city, and so. So I will show you how to read this data in Python. And to save a bit of time, what I did is that all the importation is already written there, so you don't need to watch me writing importation of the libraries. The interesting part will be that we're using some Seaborn library. This is for visualization. Pandas is for data manipulation. NumPy is numerical libraries. And here we have all the linear regression, ridge, lasso, and so on. And we also have how to compute the mean square error. So we read the data from the CSV file with this command. And I need to import, sure. There we go. And we can have a look to what is inside this variable. Let me show you the first 5 parameters. I'm missing, thank you. Yeah. I don't know about the font size, how you see it from there. Is okay? Shall I increase? Speak your mind, is okay? Over there? Okay. Good. And this will be for how do you read a file. So you see CSV is quite easy to read. And something we can do is understand a bit the data. And maybe we want to describe this data. So we do describe. And this is from the pandas library. We get a very high-level view of some statistics. So you know the number of reviews, we have close to 2,000. Well, the number of records, so it's about 2,000 everywhere. And number of reviews, for instance, we have the minimum is 0, the maximum is 465, and you see the median, the first quartile, the third quartile. Overall satisfaction, it ranges between 0, and usually if it is not 0, it's 4 and 5, and this is happening a lot. And what we're going to do is we're going to discard for this exercise some data that is a bit irrelevant for us. For instance, you can see that some of this data has count 0, so we don't have data for this column. So no data for country, borough, or number of bathrooms, is everything empty. So there's a convention for not a number, and it's so full of not a number that when we describe the data, we know that there is 0, that it has these values. So let me drop this, and what we're going to do is this way. We're going to drop these columns. So country goes away. We are not interested also when it was last modified. Location. I never know how to write world. It's tricky. bathroom is also empty. And the minimum stay, because in Airbnb sometimes you need to be in a minimum number of days so that they can take it, or they can take you, is also not there. Well, we need this axis 1 by convention. When you have this matrix of data, axis 0 is in this direction, so horizontal direction, and axis 1 is in vertical direction. So we want to drop like a full columns. That's why axis 1 is in down direction. Whoa. Thank you. I'm glad that you're paying attention. Wow. Still. Yes. You're right. So much better. Thank you. So we can have a look to our data now and see how it looks like. It's looking good, eh? Well, something else we could do is that we can drop the city, because every city in this data set will be Frankfurt. So if it doesn't change, it doesn't have any meaning. And for the room ID and host ID, maybe it's interesting, but for today, maybe it's a bit too much, in the sense that maybe for the same person could have the same style of pricing and so the host ID will be relevant, but we're not going into this complication today. So what I'm going to do is I copy this kind of thing, and I do for the others, like room ID. Survey ID goes away. City. And I think it's all good here, no? So this is what we are. This is what we have now. So we have a smaller city, a smaller Frankfurt area, and something we can make sure is that we don't have any missing point, because this is if you're going like an end-to-end example, sometimes you have gaps in the data, or sometimes you don't know what the values is for some parameters. So when this happens, you need to somehow deal with that. Something you can do is take the point away, or maybe you can use the mean value or median value, or build a classifier to impute this value. So there are strategies. So something we can check is if we're doing everything okay. So is something null? And then we take the sum of this. So no null values, so we're ready to go. And something we can do now is exploratory data analysis, if you like. Or maybe what we did should be maybe inside here, no? That we prepared the data, so I missed the the headline. And exploratory data analysis is a bit for problem understanding. So I choose this problem of predicting the Frankfurt house prices, because everybody has an intuition, no? That if you have the apartment all for yourself, will cost more than if you're sharing a room with the host. So you have an intuition, but still it's a good idea to know, to understand better the problem, especially if you're not that much acquaintance. And for exploratory data analysis, is for me the best is to do some plots and understand how data is in a visual way, no? And since we're going to predict the price, I thought that it's important to predict to see how the price look like. And we're going to use a seaborn in this case, and we do a distribution plot. We do Frankfurt, we take the price, and I show you in a minute with what this rook means. It's taking a while, I was thinking. Maybe it was a bit too small there. Let me just make it bigger. So this rock parameter, what it does is that you have this point to tell you what the prices is. So we see that most of the properties that are in this data set for Frankfurt cost between, don't know, a bit more than 0, I guess, no? Like if 40, 50, you don't see on the scale, and 200. But there are some crazy ones like more than 800, so it should be a super home. This one that you can have the option to to sleep on. Okay. Something we can also inspect is what about the what we want to use as influencers. So this will be our outcome of prediction. The idea is that imagine we have a property in Frankfurt and we want to know what the price should be. So we can use this kind of technique to know what a good price should be for that. So how the other variables affect the price. And something we can do is check how the room types look like. So this is our data. And we can check also how many different rooms do we have, or room types. So we can have either share room, entire home or apartment, or private room. So I will go with my intuition, will say that entire room will cost more, but let's see if it is true or not. For instance, something we can do is a box plot. Frankfurt. I want to do a box plot. My columns will be the price, and I want this to be grouped by the room type. Okay. I want the figure to be like the other one. And this is something for the axis to be in the right place. So this is a bit quite small. I don't know if you see there. So the first one, it says entire room apartment. So you see that it already cost more. The way to read this box plot is that what is inside the box is the first quartile, the third quartile, and the green is in the median. And this whiskers is like 1.5 times the interquartile. So you see that it's a lot of variation, that some people just get crazy on how much they ask for the house. But in general term, an entire home is more expensive than a private room, and a private room is a bit more expensive than a share room. From this plot, no? You can say that. So we can do similar thing by neighborhood. So maybe I just copy this, which goes faster. Yeah, it's a bit too small, but I think at least it's enough to know which kind of plot you will get. So some people is crazy about Fluhafen. No? This, the median price is 200. I don't know if you ever tried. Certainly not me. But for me, the interesting part is that there is a lot of deviation, especially on the when something is more expensive. For instance, these guys are just crazy. No, it's like 850. This is in dollars, but still, no? Per night is amazing. It's a type, could be. So what I was thinking is that instead of going to do all the plots here, which I think is a good idea, I did it myself, and I want to show it to you, so we save a bit of time. And this one contains the plots, so it's doing the data preparation. Is the same thing we discussed. And we have that, which are the neighborhoods in front for the website. This plot that we saw, and we also have longitude and latitude. So what I did is I used a different color for prices, but of course the color is normalized based on the range. And since this crazy guy put 150, it's making a mess. So what I did is that I used this trick. I said, well, plot me only those which are less than 200. And like this, you see that expensive things are not really in one area, but it's like scattered everywhere. What about reviews? This is the same thing again, but now with number of reviews. So you have the price on the vertical axis, and horizontal is number of reviews. So what I see here is that when there is 0 reviews, is you have a big range. If you have more reviews, it's like more stable. But this a bit difficult to see because everything seems to be in this area. So what I decided to do is to do a log plot. So I'm doing the log of 1 plus the number of reviews. I do this 1 plus because you know logarithmic of 0 is minus infinite, so this helps to solve it. And we see the same trend here. Okay, this is more difficult to interpret the x-axis because now it's the log of the number of reviews, but the intuition is there. What about satisfaction? Well, for those who have, this is like the number of stars, no, that you put in. This is a clear trend. No? The more stars you have, the more the price you can ask, which makes sense. But there is also plenty of places where you have no rating at all and ranging everywhere, the prices. Bedrooms doesn't tell us much. It's everywhere. And accommodates, this means it's different from bedroom in the sense that maybe in some bedroom you can fit several people. So accommodates how many people fit in the place. So it's also you have for every kind of accommodation, every price. So far, this is for, like say, exploration. Now we understand a bit better the problem. I don't know if you have any question on the exploration part, or shall we start with the feature engineering? What's your taste?
Yep. It's better with a microphone because we are recording.
Okay, in this last plot, it seems to be a trend, which is against the intuition, which is like a maximum around 4. More or less in this last plot.
Mm-hmm.
In this case, how would you handle this situation? Because from this plot, okay, it is not okay. In this case, I think it is obvious that there is no pattern, because the higher the number of accommodates there is, the higher it should be the price. But if it was a parameter, a feature that you don't know that precise, the behavior it should be, how would you know that if this should be considered a feature or not?
I won't. So I will just put the data in, and maybe it works, maybe it doesn't, and if it doesn't, analyzing the error, I will figure out. So it's exactly as you say. If you remember the previous session, something we can do is error analysis. So we have the training data and the testing data, and if the error is not enough in the training data, so if the error is not enough, if we're not happy with the error with the training data, it means that our model is not able to learn what we wanted to learn. So this is an indication that we need something else. So we need more data, or we need more features. And at this stage, we will think what we need. But maybe we don't need more features because we have some information already that we don't know. What I see is that some people is already a bit nervous and looking at the clock. So something I can show you is a bit of how this may play, because I've been exercising also for myself. And maybe we can have modifications on whatever you like. So this is the same thing as we had before. And for feature engineering, what I did is I put the log reviews, because in the plot we saw that the log was giving some of better intuition. And I computed this new feature, like a bedroom per accommodate, so like a ratio on how many bedrooms per people that can accommodate a flat. So when you see the table, you see these new two columns, log reviews and bedroom per accommodate. Okay. And then this a question I have is, well, there are many properties without any reviews. Shall we remove or not? So, well, let's do something. Let's do the analysis with and without, and we see the difference. The other thing is how to encode the neighborhood, because you cannot put to a linear regression the name of, let's say, Hauptbahnhof or Flughafen or West-End, Süd. No, you need to encode it. And a way to do it quite easily with this pandas library is called getDummies. And what it means, or what it does, is that you will have new variables. I cannot show somehow. Now here it is. So the neighborhood, it will transform to a vector, which is, or to a variable which is 0 or 1 depending on the neighborhood. So for instance, here we see that this one is West and Süd is here. And the same for the other. So you have all these new features, which you have 0 if it's not the neighborhood, and 1 when it's the neighborhood. So it's a way to encode it. There are different ways, but this is one of the possible way we can have. It's called one-hot encoding. So now we prepare the data. So our X is the same thing, but we don't want the price on it, because it's what we want to predict. And Y will be the price. So we have X and Y. We split the data in two. So this is a scikit-learn function that randomly split the data. And we scale the data. So if you remember that where we have this bowl that allows to go quickly in the convergence. Otherwise, if it won't scale, we have it elongated. So let's define a baseline. And this baseline, I mean, it's an easy one, but it's super easy and super fast. From the training value, I took the median price. And then I compute what would be the error if we use the median price of the training compared to the testing data. And this would be our baseline error. So just taking the median, we have plus minus $63 difference, which is quite a lot, no, for Airbnb. And the machine learning part, this is I wanted to do more slowly, maybe. This part is what we discussed before. Sure. No, we didn't.
Okay.
No, but the idea is that we can run it like this and run it removing it and see. I don't know how. Maybe we can do a survey. Do you buy something on Amazon, surf Airbnb if you have 0 reviews? Never. I don't. Okay, you do? At least I won. Early adopter is good. So to make it maybe a bit faster, what I did here is that let's try everything. So we try linear regression, we tried Reach, Lasso, and ElasticNet, and we tried all these alphas and all these R that was playing during the theoretical part to get the best results. And this is what we get. So for linear regression, the training error will be $49 plus minus. And in testing is terrible error, you see, is times 10 to the power of 13. So there's so many features that somehow it overflows, so it didn't manage to converge. With Reach, we get something much more reasonable. Also on testing. So testing is the part that we want to understand how it generalizes, how it or how it performs with data that was not seen before. Lasso is also doing a good job. ElasticNet is also similar. Since I know that Lasso removes the features which are more irrelevant, I wanted to show you the coefficients. This is the coefficient for Lasso. We have so many because every neighborhood is encoded as its own feature, if you like. And I'm showing a bit which are I order them so that what is biggest come first, and you see what is more important is if it is the entire home, you have like a 19.7 importance, number of bedrooms, setback, looks like it's expensive, no? How many people it accommodates, and this is sort of prediction. And something that I did is, let's do an error analysis, and so here I get the prediction, because I'm not happy with the training performance. If you see the training performance was like 49. So for me, $49 plus minus in Airbnb is not a good error. So, and the test error is about the same. So the problem is not that it's not able to generalize. The problem is that it's not able to learn. So I want to know what's wrong with the learning. And what I did is I predicted with this function. So you can do Lasso, for instance, predict, and you get the prediction for the train values. And the difference will be the difference between prediction and so the prediction and what's the real value. So we have something like this. So we have around 0 is most of the data. So we have a good prediction most of the cases, but some cases we don't have a good prediction. And the prediction is so wrong, some cases that is making our average error very big. So what I will propose is to find out what's wrong with these predictions. And what I did is, let's split the prediction in two. So the one with the high error, let's put it a bit more on top. will be the one where the absolute error is more than $80, and the one which are good are less than $10. So plus minus 10, I think is good. So for this split, I have 71 cases where we had a high error, and 1,388 where I have a very, very good low error. And let's plot distribution and see how it looks like. So this is how to plot it. And I'm plotting an histogram of everything. I mean, you can go more sophisticated, but I think with an histogram give us an intuition. And what I'm looking for is for different shapes. So if the distribution is about the same for the good and for the bad, it means that I should look somewhere else. So I look for something where the bad are different from the good, and this will give me an understanding where I should go more. So this is for number of reviews. So blue is when we have a low error, and red is where we have the high error. Overall satisfaction is a bit different, but not too much. Accommodates. You see, the accommodate maybe is a bit different here. So for 0, 1, 2, 3 is about similar, but for this right part is having trouble. No? When you have more people, it's more difficult to estimate. Number of bedrooms. Yeah, if you have more, like a 2, 3, it's also more difficult to estimate. Latitude, longitude, it looks a bit different, but the scale is also different, so I don't trust this thing. So there should be a better way to do it. But look at the reviews, at the log reviews, how different it is. So to me, it's something that we can have a look to the number of reviews. Here is about the same. It doesn't look like because of scale, and it has also more problem when it's the entire apartment. You see, when it's the entire apartment, it's more difficult to predict the price, because I guess people can ask you whatever they want for the full house. And also for a private room, it's more difficult, while for the share room is about the same. And for the neighborhood, for what I look, it doesn't make much of a difference. So it's all neighborhoods are here. It's about the same. So as many of you, yeah, it's about the same. As many of you already had the intuition, is mostly the number of reviews, and it's more interesting to see that in the log of reviews, because you see how different it goes. So something we can do is repeat this exercise with a higher number of reviews. And I don't know, how many reviews do you want to see before you buy? I don't ask to Pablo because you buy with 0 reviews, but everybody else? At least 3? 10? Which number shall we say? 7? As you like. We can try all different techniques. So where we have that? Higher? Ah, yes, here it is. So this is my trick. You see, I put 10 because this is what I look for. But maybe we can do 10 and we can do 7 after. So before we have close to 1,000 data points, and after removing those who are less than 10 reviews, we only have 483. So most of the properties in Airbnb have 0 reviews, at least at the time that it was 2007, this data. So we can continue with this, and we will get now a new baseline, because now we have less data. So before was $63 plus minus, now it's 41. So it really helps, even just predicting the the median price. Let's go for the machine learning. So, bed 31. And now we can have a look what is more important. Still quite similar. You see now the overall satisfaction start to have an influence. Before it didn't have an influence because we put together things, we have reviews, not reviews. Now it plays a role, no? The having how many stars if in the house in the place you have. And some of neighborhood. This Gallus is also quite expensive, what you see in the other graph. And now we go with our error. Now you see that we have a much lower errors, particularly on the streams. So it's mostly around 0, and this is better. So you see, this is a bit more or less the process we do. We have some understanding of the problem. If you don't understand, you do some plotting and try to understand, and especially if you have access to expert to know more about the problem, it helps a lot. Do some plotting. Have a very simple baseline. If there is none, sometimes it happens that there is already a baseline. Some people does it already in a certain way, so you can use this as a starting point that you want to improve. In our case, we took just the median as a simple thing, but super fast to compute. And we managed to bring the baseline like $10 better. So we are $10 better than the simple baseline, but also it's a simple model. And we also learn from errors. So we have analysis of error. We check what influences. And in this case, the data was very noisy in the sense that for if you have no reviews, I guess that some people, what they will do is, I put my apartment for whatever maximum amount happen to be there. And if people click and buy, I'm all set. But usually people don't do that. Unless it's a good price. I guess that's what you're doing, Pablo. It's a good price. And then what happened is that what goes continuous and get reviews at the end gets more stable and is easier to predict. This is my take with this exercise. But I don't know if you want to try something else or you will have other comments or other interpretation. I'm also fine.